This section is on systems of linear equations in 3 variables. So what if we're looking at 3-dimensional space and we have planes that are intersecting? What kind of solutions can we have? So you can see here on this first page, we could have solutions of where the think of 3 pieces of paper could intersect in one line, or they could intersect in a point, or they could be parallel and be no solutions. So those are the 3 possibilities for solutions for a system of 3 variables equations. So our equations are going to be in the form ax plus by plus cz equals d. So this is the way that they need to be written in order for us to solve them. And there are possible solutions again. We could also have a consistent system where all 3 pieces of paper are the same piece of paper. All 3 planes are the same. Or we could have an inconsistent solution or no solution where the 3 pieces of paper form to make more than one line or more than one point. So, first of all, show that this ordered pair is a solution of the system. So this isn't so bad. We're just going to take all 3 equations and plug in the point, just like we did with systems of 2 equations. So for the first one, we have x minus 2 times y plus 3 times z, and we want to know if that's equal to 22. So we've got negative 1 plus 8 plus 15, and that is, in fact, equal to 22. So the first one, we're all good. For the second one, same deal. Plug in our point. So 2 times x minus 3 times y minus z. We want to see if that's equal to 5. So we have negative 2 plus 12 minus 5, and that is equal to 5. And then the last one, 3 times x plus y minus 5 times z. Does that equal negative 32? So we have negative 3 minus 4 minus 25, and that does equal negative 32. So that means that this point, negative 1, negative 4, 5, is a solution to our system. Okay, so how do we solve these things? Well, here's a bunch of words you can read through, the explanation, but I'm going to just go ahead and go for it. So, what we want to do is we first need to make sure that the equations are in the form ax plus by plus z equals d. Okay, all these are in that. We've got x plus y, we've got x, y, z equals, x, y, z equals, x, y, z equals, we're good. Second, we're going to give each equation a name. So the first one I'm going to call A. The second one is going to be B, and the third is C. So, what we do is we're going to take 2 of these equations at a time and cancel out the same variable. So with the first one, let's focus on canceling out z. That's not too bad. That just means that if we've got a positive z or negative z here, we need a positive z in the second equation, or b. So we're going to take a and then add to that Why in the world? Negative b. Okay, so a was x plus y minus z equals negative 4. And if we multiply everything in b by negative 1, we get negative 2x plus y plus z equals positive 7. And so we're going to take these and add them. When we do that, our z's will cancel out. So we've got negative x plus 2y equals 3. Now that's all fine and dandy, but we've still got two variables. So what we need to do is we have to take two more different equations. Okay, we can use a again, but we can't use a and b together. Or we can use b again, but not a and b together. So we need to take two separate equations and also cancel out z. So this time, if we look at c, that's x plus 6y plus 2z equals negative 1. To cancel out the z, we could multiply everything in a by 2. That would give us a negative 2z there. So we're going to do 2a. So 2x plus 2y minus 2z equals negative 8. And add those. So we've got 3x plus 8y equals negative 9. So now we've got two equations with the variables x and y. So what we do is we take those two equations, and they were negative x plus 2y equals 3, and 3x plus 8y equals negative 9. And we're going to solve them just like we did solving systems of linear equations in two variables. So for this one, if I multiply the first one through by 3, then that'll give me a negative 3x, and on the bottom we'll have a positive 3x, and the x's will cancel out. So we've got negative 3x plus 6y equals 9, and 3x plus 8y equals negative 9. Add them, our x's go away, so we've got 14y equals 0, so y is 0. So we found one of the variables. Now it's not so bad to go back and find the rest. So I'm going to take this first equation up here, negative x plus 2 times y equals 3, and plug in y equals 0. And that'll allow me to find 3. So x is negative 3. And last, we need to pick one of the other equations. I'm going to pick the first one, a. And plug in for it. So the first equation was x plus y minus z equals negative 4. We found x to be negative 3. Y is 0. And so now we can solve for z. Add 3 to both sides, and divide by -1, z is 1. So the solution to our system is the points -3, 0, and 1. And yes, we're going to go through and do this several more times to make sure you understand. There is I actually went through and drew a picture of these with my computer, and there's the solution, believe it or not. Okay, for example 3, we're going to go through, do the same type thing. So I'm going to let the first one, we got to make sure we're x, y, z. We're not. So the last equation needs to be rewritten to be 6x, add 3y, plus z, and then we're just equal to 0. Okay, and we're going to call that one C. The first one is A, and the second is B. So let's start by getting rid of Z again. Oh, another thing that would be nice. What if we take A? Oh, gosh. Let's get rid of these fractions. They're a pain. So, to get rid of the fractions, we can multiply everything through by 6. Our common denominator would be 2 times 3, or 6. And that would give us x plus y. No. Sorry. 6x, maybe one day, minus 3y plus 2z equals 30. And so that's going to be our A. Okay. So, we're going to go through and start by getting rid of z. If I use A, it's got a positive 2z, and B, which has a negative z, and just multiply B by 2, then that'll get me what I want. So A was 6x minus 3y plus 2z equals 30. And then we're going to do 2 times B. That gives us 2x minus 2y minus 2z equals -2. Add. So we have 8x minus 5y equals 28. So there's our first equation. For the second one, we also have to get rid of the z. And if we just take B and C, if you'll look, we've got a negative z and a positive z there. So that's positive, or a good thing. So we'll take B, which was x minus y minus z equals -1, and C, which is 6x plus 3y plus z equals 0. And add them. So our z's go away, and we're left with 7x plus 2y equals -1. So now we have these two equations. and we need to use them to solve for either x or y. Oh, forgot my y there. Okay, let's get rid of the y. If we want to do that, then we would multiply the top. We can get our negative 5y and our positive 2y to be negative and positive 10. So multiply the top by 2. That gives us 16x minus 10y equals 56. And multiply the bottom by 5. That'll be 35x plus 10y equals negative 5. And add. Our y's go away, and we have 51x equals 51. So x is 1. Okay, well good. We found the first one. Now we can easily find y. So I'm going to take the 8, this equation up here. You can use any one. So 8 times x, which will be 1, minus 5y equals 28. And solve for y. Y is negative 4. And then last, I'm just going to take, let's see, which equation? B will be the easiest. So we have x minus y minus z equals negative 1. And we've got that x was 1, y was negative 4, minus z equals negative 1. So we've got 1 plus 4, that's 5. Subtract 5 from both sides, divide by negative 1, and z is 6. So our solution point is 1, negative 4, 6. Okay, we've got 3 more examples just so that you make sure you have the hang of this. So example 4, we need to be in the form a plus b plus c equals d, and we're not. So we need to get there. So the first one, we just need to, I'm going to start by adding 2x to the left. Y's already there. Subtract 3z. And negative 3 is left on the right. So that is A. For B, we need to do some distributing. It looks like I've got a problem here with B too. This should say equals negative 6. Okay, so for B, we need to multiply through. So we've got 4x minus 6y, and then plus our 2, well, yeah, that's not a y, that's a z. I'm going to go ahead and put it over here, minus 6z plus 2y equals negative 6. Oh gosh, I wish that would stop. I'm accidentally hitting the little arrows at the button at the bottom, and it's a pain. Okay, so let me make sure I've got that right. And then C just needs to be rearranged. So 3x first minus 2y plus 4z equals 1. Okay? Okay. So now we need to get rid of something. So I'm going to start by getting rid of z. Okay? So if we take a and multiply through by 2, then we get 4x plus 2y minus 6z equals negative 6. And then we're just going to use straight b. So 3x, I wrote that wrong. Okay, let's start again here. We're going to multiply a by negative 2. So negative 4x minus 2y plus 6z equals positive 6, and then just b. So we've got 4x plus 2y minus 6z equals negative 6. When we add these, you see everything cancels out. So what that means is that we're going to have, since that's a true equation, we're going to have a dependent solution. If this wasn't true, we'd be done. No solution, done. Since this is a true statement, 0 equals 0, and we have a dependent solution, we need to find that dependent solution. Now this is going to be a case where if there can be many solutions along this line where they've crossed, but they can only be a set kind of solution. So our answer is going to be in terms of one of our variables, and we're going to make it in terms of x. So here's what we do. I'm going to take the first one and get rid of, or I'm going to start by getting rid of y. To do that, we'll multiply a by 2. And then we're going to use c. When we add, the y's go away and we get 7x minus 2z equals negative 5. So, since this is dependent, what we're going to do is we're going to solve for z so that all our answers are going to, our solution is going to be all in terms of x. So to solve this for z, subtract 7x from both sides. And then divide by negative 2. So we'll have, if we're dividing by a negative, then we'll have positive 7x plus 5 divided by 2. Okay. Okay, so that is what we have for z. Now we need to find something for y in terms of x. So we're going to take two of our equations and get rid of z. And that way we can solve for y like we did here and be in terms of x. So we're going to use 4 times a and 3 times c in order to get rid of our z. So we have 17x minus 2y equals negative 9. Solve for y. Divide by negative 2, and so we can get a positive 17x plus 9 divided by positive 2. So, here is our solution. We have a solution where we have x and y is dependent on x. So y is 17x plus 9 divided by 2. Z is also dependent on x. It was 7x plus 5 divided by 2. And this is where x is any real number. Okay, so that's how to solve a dependent solution with 3 variables. And here, guys, you may solve this differently. You may get rid of something else first or use a different dependent variable. That's okay. It will still give an equivalent answer. Hopefully, if you have to do this in Alex, it will tell you which one it wants to be dependent so that there's not many different solutions you could have. Okay, so last 2 examples are applications. So this first one wants us to find the quadratic function whose graph passes through these 3 points. So we found linear equations that pass through 2 points. Now we're going to find quadratic equations that pass through 3 points. And in order to do that, we use a system of linear or of quadratic equations. So we're going to write 3 equations in the form y equals ax squared plus bx plus c with these points. So here is what we do. With the first point, we're going to call this the A equation. We plug in 1 for x and 4 for y. So we have A times 1 squared plus B times 1 plus C equals y, which is 4. I need to move this over some so I have some more space. Okay. And simplify. So that's 1a plus 1b plus 1c equals 4. Same thing for point the 0.21. So we have a times 2 squared. Oh gosh, getting frustrated. Okay. Plus b times x, which is 2, plus c equals y, which was 1. So 2 squared is 4, so we've got 4a plus 2b plus c equals 1. And then the last equation, c, is going to use the points, oh my goodness, 3, 4. So a times 3 squared plus b times 3 plus c equals 4 gives us 9a plus 3b plus c equals 4. Taking these to the next page. Okay, so here's our 3 equations, A, B, and C. And so we're going to go through the same process as we've been to solve for A, B, and C instead of X, Y, and Z. So first, let's start by getting rid of C. So if we do negative A, that gives us negative a minus b minus c equals negative 4. And then use b, which was 4a plus 2b plus c equals 1. And add those, then that will get rid of our c's. So we've got 3a plus b equals wait a minute. I think I did something wrong in my example. So negative 3. So we're going from scratch here. Okay, I need to get a pencil and write this stuff down because I've made a few mistakes on my paper. So excuse me for 1 second just to make a little mark. Okay. Okay, so now let's take 2 of the equations and get rid of C, two of the other equations. So this time, let's do negative A again. And C. Add, gets rid of our C's, and so we've got 8A plus 2B equals 0. Okay, so now we've got our 2 equations. And we're going to use them to find A. So let's get rid of B. In order to get rid of B, we can multiply just the first equation by negative 2. So that we'll have negative 6a minus 2b equals something's wrong. Oh, yeah, my problem was wrong. So equals 6. And then we've got the second one, 8a plus 2b equals 0. So our b's will go away, and we have 2a equals 6. So a is 3. And so now we can go back and find our other equations, or our other variables. So 3 times, I'm just using that first equation up there, 3 times 3 plus b equals negative 3. Subtract 9, we've got negative 12. And then if we go back to the first equation, a, we had a, which was 3, plus b, which we just found to be negative 12, plus c equals 4. So 3 minus 12 is negative 9. Add 9 to both sides, and we have 13. So our solution is the point, well, we don't have a point this time. It's where a is 3, b is 12, or negative 12, and c is 13. So a is 3, b is negative 12, and c is 13. So our equation in the form y equals ax squared plus bx plus c, we're just going to fill in. So y equals 3x squared minus 12x plus 13. So that's how we write the equation of a parabola, a quadratic function, through 3 points. And then our last example, we've got a triangle. It says the largest angle in a triangle measures 22 degrees, more than 3 times the smallest angle. So let's write this. The largest angle, we're going to call it Z. We're going to call the smallest angle X, and our medium angle Y. So we've got that the largest angle is 22, where was I? More than oh my gosh, 22 more than 3 times our smallest. Okay? It says the middle angle measures 4 more than the difference between the largest and the smallest. So the medium angle is 4 more than the difference between the largest and the smallest. So large minus small. And it says find the measures of all three angles. Well, we don't have a third equation, except we know that if you add the three angles in a triangle, you always get 180, right? So these are our three equations, but we need to rewrite them to be in a form that we can do something with. So for the first one, we've got 3x, we've got x, y, z equals, right? So 3x, we don't have a y. I think I've messed up here on my paper again, so I'll mark that. So we've got 3x subtract z, and then we're going to get the 22 over, so negative equals negative 22. For the second one, we've got going to add x to the right, so we've got x plus y, subtract the z over, and we get that that is equal to 4. And then the last one we already have x, y plus z equals 180. So that's going to be our C. There's B and A. Okay, so let's start by getting rid of x. If we do negative b, then we have negative x minus y plus z equals negative 4. And add that to c, we find out that something lovely happens. We get rid of two variables at once. The x and the y both go away. That saves us a little bit of work. So we've got 2z equals 176, or z is 88. Okay, so now we need to find x and y. So if we go back up to this first one here, where we've already solved for z, then that's nice. No, let's not do that. Let's go, we want y, right? So let's go to the second one where we've got solved for y. So we've got y equals z, which was 88, minus x plus 4. That's not helping us either, is it? Yeah, we got to go to the first one. I guess there's just one more variable. So, back to the first one. We've got z is 88 equals 3x plus 22. So now we can solve for x. It'll be 22. And then we can plug in our three equations. Just want to make sure I did that right because my A was wrong above. Yeah. Okay, so we've got our two angles, and now we can plug in to find the third. So we have 22 plus y plus 88 equals 180. So y will be 70. Therefore, our angles are 22 degrees, 70 degrees, and 88 degrees. Okay, and now this section is finally over, and I hope this helps you out. And again, sorry about the screaming at my cat. Have a good day.